Hey everyone, so now that we know how to multiply monomials and binomials, we're going to take a look at multiplying binomials and trinomials today. So just a refresher, binomials are expressions or polynomials that have 2 terms, and trinomials have 3 terms. When multiplying binomials and trinomials, there are 2 methods that you can use, the box method, or you can distribute. This is also called partial products, and we're going to take a look at both of these today. So the question is saying, simplify the following, write your answer in standard form. And for this example, we're going to take a look at the box method. Okay, so whenever you're starting the box method, well, one, I want to just go over how we know to use the box method. Here you can see there's no plus sign or no subtraction sign in the middle of our parentheses right here. So we know we're going to be multiplying. And if we're multiplying, then we know we can use the box method. So the first thing that we need to draw is a box. From there, we're going to write our binomial on the side of the box that has 2 spots. And then we're going to write our trinomial on the side of the box that has 3 spots. So let's fill that in now. Okay, so we have 4a plus 2. We're going to put the 4a here, and then we're going to put the plus 2 here. Please make sure you keep the addition and subtraction signs with the polynomials so you know if you're going to treat it like a positive or a negative. Now we're going to put our trinomial on the top. So we have 6a squared minus a plus 2. Like I said, keep those addition and subtraction symbols with the terms so you know if they're going to be positive or negative. Now from there, we are going to multiply. So remember, you're going to multiply based on the corresponding side. So the first thing we're going to do is 4a times 6a squared. That's going to go in this first box. So if you want, you can fill in some invisible exponents if it's going to help you multiply in the end, and some invisible coefficients. So remember, if a variable doesn't have an exponent, it has an invisible coefficient of 1, invisible exponent of 1, and if it doesn't have a coefficient, it has that invisible 1 in front. So now let's multiply. We'll go back to red. Okay, so 4 times 6 gives us 24. And then don't forget you have to add your exponents of like bases when you're multiplying. 1 plus 2 is going to give us 3. So this is 24a to the third. The next one we're going to do is we are going to multiply our 4a and our negative 1a. So remember, multiply your numbers in front and add your exponents. 4 times negative 1 is negative 4. Add your exponents here. 1 plus 1 gives us 2. Next, we're going to multiply the next row. So we have the next column. We have 4a times positive 2. 4 times 2 gives us 8. And in this case, that 2 doesn't have a variable, so we have nothing to add our exponent to, so we're just going to leave it as 8a. Now let's move to the second row, the row with that positive 2. So now we're going to do positive 2 plus 6a squared. Now this 2 doesn't have a variable, so we don't need to worry about adding any exponents for this whole row. Because it doesn't have a variable, we can't add anything, we can't add any exponents because it doesn't have a variable. So we're just going to be multiplying 2 to all the coefficients here. Okay, so 2 times 6 is going to give us 12, and then bring down that a squared. 2 times negative 1 is going to give us negative 2, and then just bring down that a, and then 2 times 2 gives us a positive 4. Now from here, we have to identify our like terms. So remember, like terms are terms that have the same variable and the same exponent. So in this case, we have this negative 4a squared and this 12a squared, and then we have this 8a and this negative 2a. So remember, when we have like terms, we're going to add them together. So I'm going to just show that on the side over here on this other side of the line. We have 12a squared, and then we're going to add negative 4a squared because they're like terms. Different signs you subtract, keep the sign of the larger. So 12 minus 4 is 8. And then do not add the exponents here. Please keep that in mind. Whenever we're adding polynomials, we're combining like terms, we're not touching the exponents. So now we know this is 8a squared. And now I'm gonna add that 8a and that negative 2a. Same signs, same concept as before, different signs subtract. So 8 minus 2 is going to give us 6. Keep the sign of the larger. And don't forget to include that a. So now this is a positive 6a. Now when we go back to our box over here, we see that this 24a to the third didn't have any like terms because nothing else had an a to the third. And then this plus 4 didn't have any like terms because that's the only constant. It's the only one that doesn't have a variable. So I'm going to just bring those down and put them on the side. So we have a 24. Actually, I want to do this in red. We have 24a to the third. Now this was a positive 6a, so I have to put a plus there. And then, so I'm just bringing this down. And then that plus 4. Now remember, it said write your answer in standard form up here. So we need to make sure that our exponents are going in descending order, so from largest to smallest. So when we take a look at our exponents, we have 3, 2, indivisible 1, and this has an exponent of 0. So our answer is in standard form. So then we can put a box around our answer to show that we're done. Okay, so that is multiplying a binomial and a trinomial using the box method. We're going to take a look at one more example, and we're going to use the distributive method here. The distributive method, sorry, I can't speak. And it's also called partial products. So distribute, we want to simplify the following, write your answer in standard form. So the first thing that we want to notice is that there's nothing in between these parentheses, so we know it's multiplication. And a personal thing that I like to do is we can see here, unlike the example that we just looked at, the trinomial is written before the binomial, which is fine because we're still multiplying. Multiplication is commutative, so that means we can switch it around. But I don't like the way that looks personally. So the first thing that I do is I switch it. I take my binomial and I put it in front. I take my trinomial, I put it in the back. So this looks just similar to what I've been doing. Now, like we said, we're going to distribute. So basically what we're going to do is we're going to take this negative, this 2x, and we're going to distribute it to everything inside the second set of parentheses, to this trinomial. Then we're going to do the same thing with this negative 4. We're going to take this negative 4, multiply it to everything inside that set of parentheses. So I'm actually going to draw these arrows. So we have 2x times everything. So we have 2x times x squared, 2x times 6x, and 2x times negative 4. So remember, when you're multiplying monomials, you are multiplying coefficients, adding exponents of like bases. If you want to fill in your invisible coefficients and your invisible exponents, go ahead and do that if it's going to help you. Just so you know where these numbers are coming from. So we're going to multiply our coefficients. 2 times 1 gives us 2. And then add those exponents. 1 plus 2 gives us 3. Same thing, multiply the coefficients, the numbers in front of the letters. 2 times 6 is 12. Add your exponents. 1 plus 1 is 2. Multiply your coefficients. Here we don't have a variable, so you're just multiplying the bigger numbers. 2 times negative 4 is negative 8. And this negative 4 doesn't have a variable, so we're just going to bring that x over. So I'm going to write that right underneath our original problem as we move forward. We're not done yet. I'm just rewriting this right underneath this. And this is, you don't always have to do this on the side of your paper. Like if you can do this in your head, that's fine. But I like to show the work because then if I made a mistake, I can easily see where I made a mistake because I'm showing all of my work. Okay, so from here, I now want to multiply my -4 to everything inside the parentheses. So I'm going to distribute that -4 over here. So we have -4 times x squared, -4 times 6x, and -4 times -4. So I'm going to just fill in our invisible coefficients and exponents where I see the need. And that's really the only place I need it. So this -4 does not have a variable. So you do not have to worry about adding any exponents here because it doesn't have a variable. It doesn't have an exponent to add to. So we're really just going to be focusing on our bigger numbers, our coefficients, and making sure we're just doing that multiplication the right way. So we have -4 times 1x squared. That's going to give us -4x squared. So remember, don't touch that variable, don't touch that exponent, just bring it over. We do not have an exponent to add to it. Now -4 times 6x gives us -24x. And then -4 times -4, that gives us a +16. Okay, so I'm going to write our answers here right under our first product that we got when we did distribution. But I am going to stack the like terms. So that's really important. I don't want to just stack whatever. I want to make sure that my like terms are stacked on top of each other. So then when I combine my like terms, they're in the right spot and I won't have to worry about having to move things over again. So this -4x squared, I'm not going to put it directly under the 2x to the third. Why not? Because they are not like terms. I'm going to put this -4x squared under whatever term also has an x squared, which is this 12x squared. And I'm going to do that in a second. Same thing with this -24x. I'm going to put this term underneath anything that has just an x. So no exponent here. So it's going to look like this. So I'm going to put my -4x squared underneath the 12x squared because they're like terms. And then I'm going to put this -24x under this -8x because they're like terms. Now that +16, that doesn't have any like terms. So I'm going to just add it at the end. And I'm going to just bring it down when we add it all together. So now here we're going to add our polynomials together. 2x to the third doesn't have a like term, so I'm going to just bring it down. Now we're adding +12x squared and a -4x squared. Different signs subtract, keep the sign of the larger, so you're going to get a +8x squared. -8 plus -24, same signs, add and keep. That gives us -32x. And then this 16 didn't have anything to add to it, so we're going to just bring it down. Okay, last step, we have to make sure we're understanding what our question was asking us. So remember, it's asking us to write it in standard form. So let's double check. Are the exponents going from largest to smallest? We have 3, 2, indivisible 1, and this is 0. So we know that we're done. Our answer is in standard form, and that's it.